Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello and good day. My name is Ahmad Rashidi bin Ismail. My matrix number B0819103119. Today I would like to share LAB3 regarding to frequency modulation, which is we apply in MATLAB application. So let's start with the introduction, which is this is a part of the input data, which is we insert in the MATLAB application, which is it includes FS, which is a simpler sampling rate of the signal. FC is the carrier frequency, which is the value is 100. The sampling items, this is the formula, which is T is equal to 0 Fs over Fs. Next, this is the frequency of the information signal, which is one is times sinus 2 pi ft. So in this case, the value of the frequency is 2 hertz and the deviation frequency is 50 hertz. Next, the MATLAB process, which is include the two type of signal, which is the frequency modulation or FM mode, which is represented by the Y signal, and the Z signal represent the FM demodulation signal. These both signal represent the signal from the transmitter and also the receiver circuit. Next, this is the output data, which contains the three output: plot output 1, plot output 2, and plot output 3. So for plot output 1, which is represent the S1, where S1 is the value is the represent the information signal. For output 2, which is plot TY, Y is represent the FM modulation, which represent the frequency signal of the FM modulation. And next, output 3. Output 3 is plot TZ, which is Z is represent of the FM demodulation. Let's continue to the application MATLAB works. In this case, I use the online MATLAB works. So all I have to do is I insert the coding. So this is the coding. So this is the input data, the MATLAB process, and this is the output data, which contains the output 1, output 2, and output 3. So in this case, I use the signal of the 2 hertz as the initial. So once I press enter, so this is the result of the signal. Okay, so this is the result of the signal, where it represents the output 1, the output 2, and the output 3. So what we can see, the result is that the output 1 is represent the information signal or modulating signal, which contains the 2 hertz and the amplitude of 1 volt peak to peak. Next, for output 2, this is the this is the carrier frequency. And next, the output 3 is the FM modulation, and for output 3 represent the FM demodulation. So the what we can see, the output 1 and output 3 represent the same signal and the same frequency. Okay, that's all for my presentation. So for next session, I would like to invite my friend Mr. Muhammad Shahid to present his presentation. Thank you very much.
Okay, thank you, Shahid. The the discussion and conclusion that I have been made. Okay, this is the result where I got it. Okay, for the output, one shows that information signal graph, where output 2 shows the frequency modulated signal, and while for the output 3 shows frequency demodulated signal graph. Okay, for these three, we can see that frequency of carrier in the frequency modulated signal will increase when the amplitude of modulating signal increase by comparing each of the graph. So when the input signal is at its peaks, the carrier frequency will be maximal. That means for the carrier frequency will be maximum. So maximum deviation of the carrier from its normal value. So the frequency of the carrier on the other hand will decline as the amplitude of the modulating signal decrease. So when the input signal at its lowest, the carrier frequency will be minimal to be a minimum. So minimum deviation of the carrier from is a normal value. So the output for output 3 is produce an output where its instantaneous amplitude is equal to the FM input signal instantaneous frequency. So the time in the information signal becomes smaller when we adjust the information signal to 5 Hz and 10 Hz. So we can see the gap from peak to peak getting smaller. So as the conclusion that I have been made from this lab, that we are able to understand basic concept where frequency modulation. So at the same time, we learn how to command the FM modulation and demodulation functions in MATLAB, and therefore we can just get the signal of FM modulation and demodulation by using MATLAB. So this is what I can conclude from this lab. So thank you from three of us.